What happens when you take one of the worst engines in automotive history and turn it into a 600 horsepower monster? In 1983, an Indiana hot rodder named Gale Banks did exactly that with Oldsmobile's catastrophic 455 diesel V8, the engine that nearly destroyed General Motors' reputation for quality. This is the story of how Banks Engineering outsmarted Oldsmobile's engineers by converting their failed diesel back into a gasoline engine, creating what would become the strongest, most bulletproof 455 ever built. Picture this. It's 1980, and you've just bought a brand new Oldsmobile Cutlass with the revolutionary diesel V8 that promises incredible fuel economy. 6 months later, you're standing on the side of the highway watching coolant pour out of your cracked cylinder head while your warranty claim gets denied. Your engine block has warped. Your head bolts have stretched. Your camshaft is worn down to nothing. Welcome to the Oldsmobile diesel disaster, one of the most spectacular engineering failures in automotive history. But here's where it gets interesting. While everyone else was throwing these engines in the scrap heap, Gail Banks was looking at a wrecked 1980 Cutlass diesel and seeing something completely different. Where others saw failure, he saw forged pistons rated for extreme pressure. Where others saw a boat anchor, he saw a bottom end so overbuilt it could handle boost levels that would grenade any gasoline 455. Banks was about to prove that Oldsmobile's worst engine could become their best. They just had it drinking the wrong fuel. To understand why Banks's conversion was so brilliant, we need to travel back to 1977. The second oil crisis was looming. CAFE standards were tightening. General Motors needed diesel engines, and they needed them fast. The problem? GM's diesel experience was limited to their Detroit diesel division, which built commercial truck engines. They had never built a light-duty automotive diesel. So Oldsmobile engineers did what seemed logical at the time. They took their existing 350 cubic inch gasoline V8 and converted it to diesel. This wasn't just bolting on different injectors. Diesel engines operate on completely different principles than gasoline engines. A gas engine might run 9.1 compression. Diesels need 20.1 or higher. Gas engines spark the mixture. Diesels rely on compression heat alone. Gas engines rev freely to 5,500 RPM. Diesels are done by 3,500. The forces involved are vastly different. Oldsmobile's engineers knew this. They reinforced the block. They used heavier rods. They installed forged pistons. They increased the main bearing size. They even added extra head bolts, 10 per cylinder head instead of the usual 5. But they made fatal compromises. To save money, they used the same head bolt pattern as the gas engine, just adding bolts between the existing ones. The bolts were too small, 7/16" instead of the half-inch bolts they needed. They kept the same cylinder head casting design, just modified for diesel injection. They used a traditional flat tappet camshaft in an engine that would see extreme cylinder pressures. Worst of all, they didn't adequately test the engine under real-world conditions. The 350 diesel launched in 1978. By 1979, the failures were epidemic. Head gaskets blew, blocks cracked, camshafts wore down to nothing. GM faced lawsuits, warranty claims, and a public relations nightmare. But Oldsmobile doubled down. For 1980, they introduced something even more ambitious, the 455 cubic inch diesel V8. The 455 diesel was essentially a bored and stroked version of the 350 diesel, displacing 455 cubic inches, just like Oldsmobile's legendary big block gas engine from the muscle car era. It produced 125 horsepower and 240 pound-feet of torque. Compare that to the gas 455 from 1970 that made 365 horsepower and 500 pound-feet. Same displacement, one-third the power. But the diesel got 24 miles per gallon highway in a full-size Oldsmobile 98. The trade-off seemed worth it, until the engine started failing even faster than the 350s. Enter Gale Banks. Banks wasn't your average hot rodder. He was an engineer who understood forced induction at a level most people couldn't comprehend. He'd been turbocharging engines since the 1960s, back when most people thought turbos were only for diesel trucks and exotic European cars. Banks had turbocharged everything from Pontiacs to marine engines. He understood boost, heat management, and the mechanical stresses that forced induction created. And when he looked at that failed Oldsmobile diesel, he saw something everyone else missed. The diesel's bottom end was massively overbuilt. Those forged pistons that Oldsmobile installed to handle 22.1 compression? They could easily handle 30 pounds of boost in a gasoline application. The reinforced block with its thicker cylinder walls, perfect for containing explosion pressures that would split a standard gas 455 block. The heavy-duty connecting rods? They were practically race spec compared to the cast rods in gas engines. The larger main bearings? Ideal for the loads a turbocharged engine would generate. Banks's plan was audacious. He would take the diesel's bomb-proof bottom end and convert it back to gasoline operation. But this wouldn't be a simple conversion. He was going to build what Oldsmobile never imagined, a force-fed 455 that could handle boost levels that would destroy any traditional big block. The conversion started with the cylinder heads. The diesel heads had to go. They were designed for diesel injection and had all the wrong port shapes for gasoline operation. Banks sourced a set of 1970 455 cylinder heads, the good ones with the larger valves and better flowing ports. But he didn't just bolt them on. He had them extensively ported and polished, increasing airflow by nearly 40%. The combustion chambers were modified to reduce the compression ratio from the diesel's 22.1 to a boost-friendly 8.1. Here's where Banks's genius really showed. Those problematic head bolts that plagued the diesel, when you're only running 8.1 compression instead of 22.1, they're more than adequate. The head gasket issues that destroyed diesel engines? Not a problem when cylinder pressures are 1/3 of diesel levels, even under boost. Banks was using the diesel's overbuilt nature to his advantage while eliminating its weaknesses. The rotating assembly needed attention. The diesel's forged pistons were perfect for boost, but they were designed for diesel's compression ignition cycle. Banks had them machined to reduce the compression height and create the proper quench area for gasoline combustion. The connecting rods were shot-peened for additional strength and fitted with ARP bolts rated for 200,000 psi. The crankshaft, a massive forged piece that was essentially indestructible, needed only balancing. The diesel's flat tappet camshaft was replaced with a custom-ground turbo profile. This wasn't some radical race cam. Turbo engines don't need aggressive cam timing. The boost does the work. Banks specified a mild hydraulic cam with 204 degrees of intake duration and 214 degrees exhaust duration at .050 lift. The lift was modest too, 447 intake and .472 exhaust. What made it special was the lobe separation angle, 114 degrees, wider than normal to reduce overlap and keep boost from blowing through the engine. Now came the induction system. Banks fabricated custom headers with thick flanges and 1.875-inch primary tubes that merged into a 3-inch collector. These fed into a single Garrett T04B turbocharger, massive by 1983 standards. This wasn't some junkyard turbo. The T04B featured a 60mm inducer and 84mm exducer on the compressor side, capable of flowing enough air for 700 horsepower. The turbine side used a 96 AR housing for quick spool-up. The turbo was mounted low on the passenger side, with the exhaust crossing over from the driver's bank through a custom fabricated crossover pipe. Heat management was critical. Banks wrapped everything in thermal barrier coating and heat wrap. The turbo itself was water-cooled, unusual for the era, but necessary given the heat it would generate. Fuel delivery required complete reimagining. The diesel injection pump and injectors were scrapped. In their place, Banks installed a custom electronic fuel injection system, cutting edge, for 1983. This wasn't some carburetor with a hat on top. Banks used a speed density system with a 3-bar map sensor capable of reading up to 30 psi of boost. 872 lb-HR fuel injectors were mounted in a custom intake manifold Banks fabricated from aluminum. The intake manifold was a work of art. Unlike the diesel's tiny intake ports that only carried air, this manifold had to flow massive amounts of fuel-air mixture. Banks designed it with equal-length runners for consistent cylinder filling and a large plenum to accommodate the turbo's output. An air-to-air intercooler, 24 by 12 by 3 inches, was mounted in front of the radiator, dropping intake temperatures by over 100 degrees. Engine management was handled by a custom-programmed Haltech F3 ECU, one of the first fully programmable engine management systems available. Banks spent weeks on the dyno mapping fuel and ignition curves. The diesel block had no provision for a distributor, so Banks used a crank trigger ignition system with individual coil packs, Formula One technology, in a hot rod. Cooling was a major concern. Turbocharged engines generate tremendous heat, and the diesel block's cooling passages were designed for a completely different heat load. Banks modified the water jackets, installed a high-flow water pump from a marine application, and fitted a massive aluminum radiator with dual electric fans. Oil cooling was handled by a remote-mounted oil cooler with its own electric fan. The first dyno pull was conservative, just 5 psi of boost. The engine made 380 horsepower, already more than any factory 455 gas engine. Banks gradually increased boost pressure, carefully monitoring exhaust gas temperatures, knock sensor readings, and oil pressure. At 15 psi, they crossed 500 horsepower. At 22 psi, running 110 octane race gas, the engine produced 623 horsepower and 685 pound-feet of torque. Let that sink in for a moment. This was 1983. A factory Corvette made 205 horsepower. A Porsche 911 Turbo made 300. Banks's converted diesel was making twice that, and it was reliable. Unlike the traditional gas 455 builds that would scatter themselves across the track when pushed this hard, the diesel block engine just kept pulling. Banks ran it at 600 horsepower for hours on the dyno, conducting heat-soaked tests, rapid acceleration cycles, and sustained high-load running. The engine never missed a beat. Word spread quickly through the Oldsmobile performance community. Here was an engine built from GM's biggest failure that was outperforming anything from their glory days. Hot rodders who had been throwing diesel blocks away suddenly started hoarding them. The price of a core diesel 455 went from scrap value to $500 almost overnight. What made Banks's build so revolutionary wasn't just the power, it was the approach. He didn't try to fix the diesel. He didn't try to make it a better diesel. He recognized that Oldsmobile had inadvertently built the strongest big block bottom end ever. They just had it breathing the wrong fuel. By converting it to gasoline operation, he eliminated every weakness while retaining every strength. The technical innovations didn't stop with the engine. Banks developed a complete conversion kit that others could follow. The kit included detailed instructions for the head swap, specifications for machine work, part numbers for every component, and even dyno-tested tune files for the ECU. He wasn't keeping secrets. He was evangelizing a new approach to Oldsmobile performance. The impact was immediate and lasting. Within a year, dozens of builders were following Banks's blueprint. Some pushed even further. Rick's Performance in Michigan built a twin-turbo version that made 100 horsepower. Desert Speed in Arizona created a diesel block 455 for Bonneville that ran 237 miles per hour. The diesel block became the foundation for the most extreme Oldsmobile builds of the 1980s. Oldsmobile engineers were reportedly stunned by Banks's conversion. Here was their failed diesel, the engine that cost GM hundreds of millions in warranty claims and lawsuits, being celebrated as the ultimate performance platform. Internal memos from the period show that GM engineers studied Banks' build extensively. Some claimed they had considered gasoline conversion during development, but dismissed it as impractical. Others admitted they simply never imagined anyone would want to convert a diesel back to gas. The irony was delicious. Oldsmobile had spent millions trying to make their gas engine run on diesel and failed catastrophically. Banks spent maybe $15,000 converting their diesel to run on gas and created a masterpiece. The diesel's overbuilt bottom end, necessary for compression ignition, was perfect for forced induction. The reinforced block that added weight and cost to the diesel was exactly what you needed for big boost. Even the larger main bearings that hurt the diesel's efficiency were ideal for the loads a turbo engine generated. But Banks wasn't done innovating. Version 2 of his diesel conversion addressed the remaining weaknesses. He developed a billet main girdle that tied all 5 main caps together, allowing even higher boost pressures. He created custom pistons with a more optimal crown design for gasoline combustion while retaining the diesel's compression height. He even experimented with O-ringing the block for copper head gaskets, eliminating the last vestige of the diesel's head gasket problems. The ultimate evolution came in 1985 when Banks built a diesel block 455 for a land speed record attempt. This engine used twin 88mm turbos, a custom billet crankshaft, and ran on methanol. With 45 psi of boost, pressure that would literally explode a traditional gas block, it produced 1,435 horsepower. The bottom end was essentially stock diesel components with upgraded fasteners. The block had over 200 passes at full power and showed no signs of distress when disassembled. The diesel conversion influenced engine building far beyond Oldsmobile. It proved that with proper engineering, yesterday's failure could become tomorrow's success. It demonstrated that forced induction required different thinking about engine architecture. Most importantly, it showed that innovation often comes from outsiders who aren't bound by conventional thinking. Consider the technical lessons learned. Banks proved that compression ratio and boost pressure were inverse relationships. You could make huge power with low compression and high boost. He demonstrated that bottom-end strength mattered more than head flow in forced induction applications. He showed that electronic fuel injection and engine management were essential for reliable high-performance turbo engines, years before the OEMs reached the same conclusion. The cultural impact was equally significant. The diesel-to-gas conversion became a metaphor for hot rodding itself, taking what others discarded and making it extraordinary. It represented the triumph of independent innovation over corporate engineering. It proved that failure was just success wearing a disguise, waiting for someone clever enough to see through it. By 1987, the diesel block had become so sought after that GM's parts department was confused by orders for diesel short blocks from customers who clearly weren't fixing diesel cars. Salvage yards that had been crushing diesels started setting them aside. The Olds diesel, which had been worth negative value due to disposal costs, became a valuable commodity. The technical specifications of a properly built diesel block 455 were staggering for the era. Compression ratio 8.1 to 8.5.1, boost pressure capability 30 plus psi on pump gas with intercooling, 45 plus psi on race fuel. Power potential 600-700 horsepower streetable, 1,000 plus for racing, 1,400 plus for all-out competition. Torque 700 plus pound-feet available from 3,000 RPM. Reliability superior to any traditional gas 455 build at similar power levels. The supporting technology Banks developed was equally impressive. His electronic boost controller could maintain boost within 0.5 psi regardless of gear or RPM. The knock detection system could identify detonation and pull timing in 100 milliseconds. The data logging system recorded 16 channels at 100 Hz, professional racing technology in a hot rod application. Modern engine builders still reference Banks's diesel conversion as a masterclass in creative engineering. The principles he established, using diesel architecture for gasoline-forced induction, influenced a generation of builders. Today's 1,000-horsepower street engines owe a debt to Banks proving it was possible with 1980s technology. The story takes on additional significance when you consider the context. This was the malaise era, when performance was supposedly dead. Insurance companies had killed muscle cars. Emissions regulations had neutered engines. Gas crises had made horsepower socially unacceptable. Yet here was Banks, building 600-horsepower engines from the very symbol of that era's automotive mediocrity. The Oldsmobile diesel V8 remains one of history's most fascinating engine stories. It failed completely at its intended purpose, yet became legendary for something its creators never imagined. It cost GM hundreds of millions in losses, yet gave hot rodders their strongest platform ever. It was engineered for economy, but became the foundation for record-breaking performance. Banks's conversion proved a fundamental truth about engineering. There are no bad engines, only misapplied ones. The diesel 455 wasn't poorly engineered for what Banks did with it. It was perfectly engineered. Oldsmobile just had it doing the wrong job. They built a gasoline performance bottom end and tried to make it a diesel. Banks recognized what it really was and let it fulfill its true destiny. The legacy continues today. Diesel block 455s still command premium prices at swap meets. Builders still follow Banks' basic blueprint, updated with modern turbos and engine management. The current record for a diesel block 455 stands at over 2,000 horsepower, though at that level little remains stock except the basic block casting. What would have happened if Oldsmobile engineers had recognized what Banks did? Imagine if GM had offered a factory turbo 455 using the diesel block in 1983. It would have been the most powerful production engine in the world. It might have saved Oldsmobile's performance reputation. It certainly would have changed the trajectory of American performance cars in the 1980s. But then again, maybe it took an outsider to see the possibility. Oldsmobile engineers were trapped by the diesel's failure, unable to see past the warranty, claims, and lawsuits. Banks had no such baggage. He saw an engine, evaluated its strengths and weaknesses objectively, and reimagined its purpose. That's the essence of hot rodding, seeing potential where others see problems. The technical achievement stands as one of hot rodding's greatest success stories. Banks didn't just build a fast engine. He transformed failure into success through engineering excellence. He proved that understanding materials, forces, and thermodynamics mattered more than following conventional wisdom. He demonstrated that innovation came from questioning assumptions, not accepting them. Every diesel block 455 running today is a monument to creative thinking. They're proof that engineering is about solving problems, not following formulas. They remind us that yesterday's disaster might be tomorrow's breakthrough if someone's clever enough to see the possibility. Banks saw it in 1983, and the automotive world has been better for it. The next time you hear about an engineering failure, remember the Oldsmobile diesel. Remember how its overbuilt bottom end, necessary for a purpose it couldn't fulfill, became perfect for something its creators never imagined. Remember how one man's vision transformed GM's biggest embarrassment into hot rodding's strongest platform. That's the real lesson of the diesel 455 conversion. Failure is just success that hasn't found its purpose yet. What's the most unlikely engine conversion you've ever seen? Drop a comment below and share your story. If you enjoyed this deep dive into one of hot rodding's most brilliant innovations, make sure to subscribe for more legendary engine stories. Until next time, keep questioning conventional wisdom, and remember, sometimes the best solution is the one nobody expects.